Hi everyone, in this lecture, the CMOS inverter is simulated. Now we know everything to simulate the CMOS inverter. The only we have to keep in mind is that there are two devices and they are independent. This is the circuit schematic. We have in and out nodes. Of course, the ground node and the VDD node are given. Two transistors and two voltage sources. Voltage sources are easy and we will concentrate on the devices. For transistors, they are taken from our previous project. First, consider the minimum size transistors, in this case 90 nanometer wide ones. Of course, the metal work function should be properly assigned. Two devices are independent. Therefore, we must specify the physical models for each transistor even when they share the same model. For example, if we omit the PMOSFET specification in this slide, then the PMOSFET will use the constant mobility model. This is the circuit description. It is lengthy. These four lines for the N MOSFET. Next, four lines for the P MOSFET. Check its validity carefully. Even the low specification should consider two devices independently. Therefore, for example, Poisson equation should be called twice for the N MOSFET and the P MOSFET. It seems to be quite tedious. However, independent control over each device is quite important in many cases. Now we have a CMOS inverter and physical models and equations. Let's simulate it. First, apply VDD. Then your input voltage is still 0 and your output voltage is VDD because the N MOSFET is turned off and the P MOSFET is turned on. After that, ramp up the input voltage. Since inverter has a drastic change in its output voltage, the max step value should be carefully selected. When the input voltage changes from 0 to VDD, the voltage transfer curve is obtained. Using the CSV file, we can draw the voltage transfer curve. Now we consider a case where two MOSFETs have the same width, 90 nanometer. This is the voltage transfer curve. The dots represent the point where we have solutions. We know that the P MOSFET is slightly weaker, therefore the voltage transfer curve is slightly shifted from its perfect balanced one. How can we quantify the shift? The switching threshold can be a measure. It is defined as a voltage where the output voltage is equal to the input voltage. In this example, it is about 0.55 volt, not much deviated from the half VDD. Also, the noise margin is defined with a point where voltage transfer curve has a slope of -1. Actually, we have 2 points. Therefore, we can estimate two noise margins for a low input value and a high one. Okay, that's it for this lecture 15. In this lecture, the static properties are studied. Of course, the inverter is used with a time-varying input signal. In the next lecture, we will consider the transient simulation. Thank you and see you later.